Okay, welcome back once again. Let's take a look at the remaining parts to our lesson here. We basically have a few slides that discuss how would we be able to discover any events or alarms that might appear in vSphere related to VM encryption. We'll also take a look at encrypted vMotion. Not quite the same, but and it's actually kind of an automatic thing anyway. But in any case, the encryption events and alarms, right? vSphere 7 will log warnings and errors about VM encryption in quite detailed information, which is good because it helps us solve issues when troubleshooting. So, for instance, how do you know you have a core dump? Well, there's a warning that says, hey, you have an encrypted core dump. How do you know you have an issue trying to encrypt a VM because you don't have enough disk space? Well, there's an alert for that. If you're having a key creation issue on the KMS, it'll get recorded in the vSphere client. And if the KMS server is unreachable, which is a huge issue with regards to encryption, we'll be notified of that. So these are some of the important critical events to watch out for. So having an encrypted core dump is obviously telling you that the server happened to have crashed, and it may have actually just either rebooted or it was stuck at a purple screen, but it's probably rebooted if you're getting just the warning here. But it's just letting you know that there is an encrypted core dump that exists. It's basically giving you a thing that lets you know that you should probably go troubleshoot a problem. You probably need to get this off of the system and probably get an extracted diagnostic report that has been re-encrypted with a different password. So you'll see a message like this in the ESX host, right? So you're looking at your host message, looking at the monitor tab, and under the events, we'll find an alert that tells us, hey, there is an encrypted core dump that exists. So you should consider now at this point going and either doing an export diagnostic data or even doing the VM support command that you can launch from the ESX service command line. If you're trying to encrypt a VM, and remember, when you encrypt a VM that's already out there, we're going to need to have temporarily double the storage capacity so that each VMDK can essentially have a new instance of itself so we can copy from the non-encrypted version of it to the encrypted version of it. If your space is low and you're trying to encrypt or even decrypt, because you got to do the same thing when you decrypt a VM, you need that double the capacity. So you'll need to find the data store where the encrypted VM resides and probably monitor disk space. And you may need to move the VM first to a different data store before you go ahead and try to either encrypt or decrypt it. If you have a key generation error message, right? If the KMS cannot generate a key, well, of course, that's not an error in vSphere so much. This is an error that's happening on the key management server, but you will see this alert as one of your vCenter alerts. Since vCenter is the only system who talks to the KMS, you could potentially see this as an error message showing up as a vCenter error. It's also going to show up in your vCenter server logs that sit on the vCenter hard drive. And if the KMS is unreachable, right, that's not good, because then if a host reboots, then you're not going to be able to get any keys because the host has now lost all of its keys, and those VMs will be locked until you get your KMS back. So you always want to check the health of your KMS, and if the connection is down, you'll get the KMS health status alarm triggered. So check your vCenter logs for any related messages, verify that the KMS server isn't down or powered off, and check the connection between the KMS and the vCenter. If there's a proxy, then check to see if it's still reachable, and verify if you're using the right IP addresses and the fully qualified domain names. Kind of standard, check the network settings set of troubleshooting tips here. But you definitely need to verify the status of that KMS if you're getting this error message. So that, folks, is VM encryption. What we have up next for the next couple slides is just a feature that was introduced in vSphere 6.5 right at the same time as VM encryption. But this isn't encrypting the VM. This is actually just encrypting the network that we use to migrate VMs over vMotion. So this is not involving any KMS. This is actually just vCenter making sure the data gets encrypted as it leaves the ESX server onto the vMotion network, and then vCenter will then decrypt it as it arrives the new host. So there's no extra third-party system for keys. This is basically vCenter Server creating a symmetric key that will encrypt it as it hits the vMotion network and then decrypt it when it lands back on the host. Which is cool because if you have an encrypted VM, it's critical that if now the VM is going to be migrated, it would be important that, okay, we've got the storage encrypted. What about the memory transfer during a vMotion? So in fact, you can find the status of whether or not encrypted vMotion actually is able to work. All you really need to have is the entire environment running at least vSphere 6.5. If you're running vSphere 6.5 on vCenter and the ESX servers, then everything can be encrypted. But if anything is short of that, which we probably wouldn't find too often, but if there's a host that's still running 6.0, well, then we cannot perform encrypted vMotion. Well, should we do the vMotion in non-encrypted form, or should we just block vMotion from happening altogether? Well, that's a setting you can apply to your VMs. In the VM settings page, so here we have a VM called Linux 1. Under the VM options, there are these encryption settings. There's basically, what do we do with encrypted vMotion? Do we set it to opportunistic? Do we require it? Or do we disable it? So the default is opportunistic. Basically, vMotion will attempt to encrypt whenever it can, if all the requirements are met. If not all the requirements are met, then it'll just migrate non-encrypted. That's opportunistic, right? We'll try when we can, and then just migrate non-encrypted when we can't. If you set it to required, though, then vMotion will only occur if the vMotion can be encrypted. And if it can't encrypt it, then we can't migrate. The migration will fail. And if you disable, well, then it will just do non-encrypted vMotions, kind of how we did it in vSphere 6.0. So what's the deal with this, and why is it in the VM encryption module? Well, or the VM encryption lesson. If a VM has the encryption policy applied to it, so that means we're encrypting the VM data, this will switch automatically to required. So when a VM is encrypted with VM encryption, its vMotions must be encrypted as well. If they can't be encrypted, then the VM cannot live migrate. So, and it will also be set to required and will be grayed out. You can't change it until you turn encryption off on the VM. So you have to actually decrypt the VM so that you can change this encryption, the vMotion setting. But you can't change it while the VM is encrypted. It has to be in a required encrypted vMotion condition. That gives you that extra layer of security because, hey, the VM's data is encrypted. Let's also encrypt the data while the VM is migrated. In fact, if you do a storage vMotion while also performing a vMotion, right? So you're doing the whole cross-host vMotion type of operation here, then everything is sent over the vMotion network encrypted. So we just went through all these, but as we just saw, if you had set the encryption vMotion setting to required, migration proceeds only with encryption if all sides meet the minimum requirements for encrypted vMotion. If it's opportunistic, it'll try, but if it can't do the encrypted vMotion, well, at least it will do the migration non-encrypted. And then, of course, disabled, it won't even try to encrypt the vMotion. So that is the end of our VM encryption lesson. We took a look at and have now you should be able to describe the components of VM encryption architecture, be able to manage encrypted VMs, encrypt core dumps, use encryption with instant clones, migrate encrypted VMs, list VM encryption events and alarms, and enable encrypted vSphere vMotion. And this ends our vSphere security module. The things we took a look at this module: when defining a role, use the smallest number of privileges possible to make sure you have added control. Hardening a vSphere environment to be more secure involves configuring the vCenter server system and ESXi hosts and VMs in the vSphere network. The VMCA provisions each host and each vCenter server service with certificates that are signed by the VMware CA. When encryption cannot operate without vCenter server because vCenter server communicates with the KMS and manages the keys that are used for encryption. If you can use VM encryption and an ESXi host fails, the resulting core dump is encrypted to protect the customer data, and encrypted vMotion is available for all VMs, whether or not the VMs are encrypted. So yes, that was a pretty extensive lesson and set of lessons in a module. I hope you found this useful. It has been a pleasure, and I hope to see you in class at another time.